Good morning, ma'am.
Good morning, everyone. This is not the lab, Rfid, it's the lecture. And last time, what we had done, it was mux. What do you want to say? I didn't understand. Yes, that is correct. But in the last lab, how we have done mux? क्यों ऐसा क्यों बोल रहे हो सनी? किस बात का रिप्लाई नहीं किया मैंने? uh, आपने कुछ पूछा क्या? क्या बताओ? As everyone else do. Really, Ashish? Okay, anyway, let's start today's lecture without wasting time, without discussing unrelevant things. We'll discuss this in our free time, okay? Okay, so I think yesterday we have completed the second last chapter of the syllabus. And today I'm going to start a last chapter, that is data link control. Everyone, we are going to start today last chapter, data link control. Okay, so let me share my screen first, just a minute. Okay, so see here, आपने जो भी layers पढ़े हैं, OSI layer, sorry, whatever layers you have studied, OSI layer and TCP/IP model, right? In those two models, we have studied some of the layer like physical layer, data link layer, network layer, transport layer, and so on, right? So in the second layer, data link layer, we are going to discuss the second layer, data link layer today. So two main functions are there for the data link layer. One is data link control and second is the media access control. And where the data link control is very important function of this layer. And whenever I will tell about the data link control, so data link control will do the different type of functions like framing. Framing means whenever you are combining the bits coming from the physical layer into a frame. Or at the transmitter side, you can talk in a reverse way, that from the network layer, whatever packets are coming, that will be formed in a frame, right? So framing is the first function from of the data link control. Second is flow control. Flow control means, see, whenever transmitter is transmitting some data, it is not required that receiver will receive all data. Receiver can receive all the data at a time. So maybe the speed of the transmitter and receiver or the capacity of transmitter and receiver can be different. So how to control the flow of data? That is a flow control. Second is error control. Error control means whenever you are transmitting any data, if there is an error, then that will be corrected or detected. Why I'm saying detected or corrected? Because some one bit error is there which will be detected, then it can be correct very easily. But if more number of bits are with error, then correction will always not be possible. But yes, detection is possible. So error detection and correction, so it is in general it is known as error control. So error control will also done in the data link control layer or data link layer. Okay, so let's start the first function of the data link layer, that is a framing. Data link layer needs to pack bits into frames. I told you, right, that number of bits are there in a data, right? So that bits needs to be in a form of frame. Now, what is frame? You already have studied, but I will tell you that different type of frames are also possible, right? So that we are going to discuss in this topic. So the number of bits will be packed into the frame so that each frame is distinguishable from another, right? So whenever you are sending the first data and second data, then how the first data is different from the second data, that can be differentiated by this frame structure, or the starting and stop bit and address of the source and destination. Many things will be added into this frame, right? So some data will distinguish these two different frames with each other. Our postal system practices a type of framing. The simple act of inserting a letter into an envelope separates one piece of information from the another, and the envelope serves as the delimiter. Now, let me tell you what this sentence is giving you a meaning. So they are saying that whenever you are sending a data in from form of frame, if you want to differentiate two frames, you will add some extra bits into it. Either you will say that this is a starting of first frame, this is the ending of first frame, starting of second frame, ending of second frame, or you will say that this is a source from which the data is coming, and this is a destination where the data needs to be sent, right? So some type of extra things, extra letters will be inserted into the data, and that extra letters or extra bits will represent that what this frame is about. Okay, so here in this section we are going to discuss two types of framing here. One is fixed size framing and second is variable size framing. So let me tell you, here only you have to understand the meaning of this. Okay, so fixed size framing means frames can be fixed or variable size, right? Frame size can be fixed, can be variable. So whenever you are talking about the fixed size framing, it means there is no need for defining the boundaries of the frame, right? Boundaries need not to be defined whenever you are defining the fixed size framing. Why boundaries it's not to be defined? Because the size itself can be used as a delimiter, right? So whenever you are saying that a particular frame you are sending, you are not sending any start and stop bit, but in that frame, if you are saying that this frame is of 16 bit, for example, this frame is of 16 bit, so that size of that frame itself will define that which type of frame it is, which type of data will be available into this. Okay, for example, I'm giving you the example for fixed size framing here. Whenever you are using the wide area network, right, wide area network which uses the frames of fixed size, in the wide area network, whenever you are transmitting data, it's not like that one type of data you can send with this much size, second type of data will be sent in this much size, right? So whenever you are sending the data, that whole data will be divided into equal size of packet, equal size of frame, right? So whenever you are using this type of wide area network, the data frame size will be equal for each frame. And if I am saying about variable size framing, then obviously the name itself says that size can be different for the different frame according to the data, right? According to the data. For example, in a local area network. So in a local area network, what you are doing, whenever you are sending any data, any file, then that type of file or size of file can be different for the different frame. So in the variable size framing, we need a way to define the start and stop bit into the frame, because size can be different, so you cannot recognize that okay, 16 bit is over, it means now first frame is over, so second bit frame will be automatically be started. Again 16 bit over, so third frame will automatically be started. That is possible in the fixed side framing, but variable size framing, it is not possible, because maybe first frame is of 8 bit, second frame is of 32 bit. So how you will come to know that this is the first data, this is the second data? You have to assign start of the frame and stop bit of the frame, starting bit and ending bit. Okay, so whenever you are talking about the variable size framing, this is required, start and stop bit. And generally in most of the application, we are going to use the variable size framing. Now, how this frame will be having a structure? So let me show you the frame in a character oriented protocol. So character oriented protocol means it will use, this type of frame will use a particular protocol which will define the data in terms of characters. Variable number of characters will be there. Okay, so whenever the data is coming from the upper layer, data is coming from the upper layer to the data link layer, right? The number of variables will be counted, number of characters will be counted, and that will depend upon the character oriented protocol. So one type of protocol will be used here whenever you are defining a frame. So data to be carried, whenever data you are carried from the upper layer, the each data will be of 8-bit characters, right? It should be of 8-bit characters, but if you are using a variable size framing, then the number of characters can also be different. But in one character, for example, you are saying that number of characters required are, let's say, 100 characters are allowed to send the data in a frame. Okay, so different number of characters can be there, maximum 100 should be allowed. So in each character can be represented by 8-bit. Now I think I need not to explain you the character. Character means a letter, simple a letter. Okay, so whenever you are sending any file, you are sending a letter, right? You are sending alphabets. So if you are sending the alphabet or numerical number, that will be represented as a character, and each character can be represented by 8-bit of data. So which number system can represent one character in 8-bit of data? Can anyone say? We have already studied this into the digital electronics. I repeat, one character can be represented as 8-bit. So which number system it is? Or which, actually not number system, but you can say which code system will be used. Okay, everyone is saying octal. Okay, wait. Wait, everyone. If you are saying octal or hexadecimal, let me tell you, you can represent digit in octal or hexadecimal. You cannot represent alphabets in the octal or hexadecimal. Arafat is saying ASCII. Very correct. I told you character. I told you understand the word character. Character means any number, any alphabet, any symbol. In the keyboard, whatever keys are present, those are known as a character, right? And that keyboard is working on a ASCII number system or ASCII code system. So whenever you are representing ASCII code, any character with the ASCII code, that will be represented by 8-bit. You all know this, right? Actually, it is a 7-bit code, but generally we always, Rafat, I'm coming to that point only. Actually, ASCII is a 7-bit code, but generally we are using 8-bit because we always relate every number system and code system in form of 2 raised to something, right? So 7 cannot be represented at 2 raised to something. So we'll always see, if you will purchase any hard disk or pen drive or anything, RAM or ROM or anything, right? You will get the that memory or something like digital devices in form of binary code, right? You can purchase 1 GB. You can purchase 2 GB. You cannot purchase 1.1 GB. Are you getting this? You cannot purchase 1.1 GB pen drive because it is not, it can be designed, but it is not available. Right? It is not available. So whenever we will represent any number system, we will represent it in 8-bit. Okay, so here you can say that yes, 7 bit is required for the ASCII, but generally we are using 8 bit. 1 bit will fix it. 1 bit will fix. Okay, it's 0 or 1. So, character oriented protocol, in the character oriented protocol, data to be carried are the 8 bit characters, and from a coding system such as ASCII, I already told you. Now, let me again go to the PPT. Yeah. Here, other than the variable number of characters, 4 different tabs are there. One is flag at the starting of the frame and at the ending of the frame. Flag is there. One more thing is there, that is known as header and trailer. Flag, header, and trailer. So let us understand these all 3 words one by one. For example, the header. The header normally carries the source or destination address. Source and destination address, let me tell you. Right? So from which source you are getting this data and to which destination you are transmitting this data. So that source and destination address is available into the header tab. Okay. Now trailer. Trailer bit is generally, actually it's not a bit, it's a combination of bits. So trailer bits generally carries the error detection, or you can say that redundant bits. Trailer will carry redundant bits. Redundant means extra bits. So which are these extra bits? Which will represent or which will do the function of error detection and error correction. And this is also will be in the multiple of 8 bits. Okay, why in the multiple of 8 bits? Because each character is represented by 8 bits. Header means address, so source and destination address will also be in multiple of 8 bits. Trailer is redundant bits, but redundant bits will also be in the multiple of 8 bits. Okay, next is whenever you will that is okay, header and trailer will carry the very important information, right? Source, destination addresses plus error detection correction capability. Next is flag, right? So flag is simply carries the information about the frame number, starting of the frame and ending of the frame. Okay, so to separate one frame from the other frame, 8-bit flag. Again, this will also be in the multiple of 8-bit, and generally it will be of 8-bit only, 1 byte. So 8-bit of flag is added at the beginning and 8-bit of flag is added at the ending of the frame. Okay, now if you will say that what it will carry in 8-bit, what will be the data in this flag? So the flag will be composed of the protocol dependent characters. For example, signal is starting from a particular data. So particular 8-bit combination will be there, which should be different from the data. Sometimes this problem will occur. I will explain you this in the next slide. That sometime the problem will occur that flag data and the character original data, what you are carrying from the upper layer, will be same. So at that time it will be very difficult to identify that this is the end of the frame or this is a part of a data. Right? That we will learn in the next frame, next slide. Okay, so here whenever I will say about the frame, then 3 important things are there which you have to add with data. One is header, second is trailer, and third is the flag. Header will carry source and destination addresses, trailer will carry the error detection correction bits, and third is flag. Flag will carry the starting and ending of the frame. Okay, I think that is enough to understand into the frame structure. There is so many things to understand, but here for you, for this structure, this many things, 4 parts are there you have to study. First is the data itself, second is the header, third is the trailer, and fourth is the flags. Okay, now next is byte stuffing and unstuffing, and byte is required actually. Byte stuffing, the name itself says that we are adding 1 byte into the data or in between the data, right? So we are stuffing the byte in between the data and unstuffing that same byte at the reception side. right? At the transmitter side, we are stuffing the byte. At the reception side, we are unstuffing the byte. So why it is required, let me tell you. That sometimes it will happen that whatever combination of flag is there, for example, this flag is having some 8-bit data, and same 8-bit data is somewhere here in the original data what you want to send from source to destination. For example, this flag is 0 1 1 1 1 1 1 1 0, right? Let's say combination of this 8-bit of flag is 0 1 1 1 1 1 1 0. Okay, and same bit combination can be there in the data, right? It can be there in the data also. So let's say somewhere in the data the same combination will come, right? So what destination will interpret? Destination will interpret that this combination is for the ending of the data. It means ending of this file is done, ending of this frame is done. So after this, the remaining data will be lost. So to remove this problem, this is the problem, right? That flag data can be same as the original data. At that time, it is very difficult to interpret that this is a part of data or this is the end of a frame. So to remove this problem, we are going to use byte stuffing. Right? To fix this problem, a byte stuffing strategy was added to this character-oriented framing. In this byte stuffing, actually it is also known as character stuffing. Why? Because one character is of 1 byte, 8-bit, right? One character is of 8-bit. That's why it is also known as character stuffing or byte stuffing. So to fix this problem, a special byte is added to the data section of the frame when there is a character with the same pattern as the flag. Right? So wherever the same pattern as the flag will come into the data, a special character, special byte will be put over there. And that special character is known as escape. Escape character. So generally, this byte stuffing, for the byte stuffing, one character will be used, and that character is escape character, which has a predefined bit pattern. And whenever escape character will come, it means it will represent that whatever is coming after this is not the end of the data, end of the frame. It is a data only. Okay, so I will explain you by this example. Don't worry, just a minute. So what will happen? Byte stuffing by the escape character allows the presence of the flag. Presence of the flag means the same pattern will be allowed into this data also, right? But it creates another problem. What happens if the text contains one or more escape characters followed by a flag? For example, like this, right? One or more escape characters are followed by a flag. Then what will happen? What receiver will do? Unstuffing. At transmitter side, you are stuffing the byte, but at the receiver side, it will unstuffing. So unstuffing means what? The escape characters will be removed, right? So at the receiver side, escape characters will be removed, but it will keep the flag bits or patterns of the flags in the data itself, which is incorrectly interpreted as the end of the frame. Right? To solve this problem, escape characters that are part of the text must also be marked by another escape character. So extra 2 bytes will be required to do this. In other words, you can say that escape character is a part of the text. An extra one is added to show that second one is also part of the text. I repeat what I want to say. See, I can explain you in the paint only because it is not, I think you are not able to understand in this type of figure. I'm taking one example so that you can very easily understand this, that what is happening actually. Let's say I'm dividing this into flag, header, flag, trailer, and this is your data. Now, what was the problem previously? Problem was in this, let's say, in between data, one character is having a same pattern like flag, right? Let's say I'm representing this pattern as a star. So I'm getting the same pattern in between the data. So whenever receiver is start reading this frame, it will first read that, okay, start of the frame is there. Then it will read the header. Then it will start reading the data. In the data, there are so many bytes, okay? So many characters. So many characters are there in the data. Now, whenever it will come to this, reading this character, receiver will start reading this character. Receiver comes to know that this is representing end of the frame, right? So if it will represent, if it will interpret that this is the end of the frame, then the remaining whole data will be lost. That we don't want. So what was the solution? The solution is we will put one escape character before this same pattern of flag. Now what will happen? Whenever receiver will start reading the data and it will read the escape character, it will come to know that after this escape character, whatever pattern is same as the end of the frame, but I have to consider it as a data. I repeat, whenever it will read this escape character, receiver will interpret that it is the escape character, means whatever is going to come after this is not end of the frame, this is the part of the data. So this is the byte stuffing. This is known as byte stuffing. And whenever receiver will read this escape character, it will remove this escape character from the data and it will continue reading next data. So escape character removal is known as unstuffing. Did you get it, everyone? Escape character is known as unstuffing. Now, that is the solution of the problem. Yes, someone is asking some question. Up to this, any doubt? What if data have, same problem I was discussing. Rafat, you are asking that what if data have also escape character? Yes, same problem I was discussing into the PPT, but I think students will not able to understand. So I'm explaining it into the paint. Now, the problem of this same pattern will be removed by putting escape character, but another problem will come into the picture. What is that another problem? That if data is having the one of the character escape, because escape is a part of keyboard, right? So in a keyboard, maybe you are clicking on the escape key. So that escape key is also one character. If this escape character is a part of data, then what will happen? Because what is the task of receiver? Whenever escape character will come, receiver will remove it. Receiver will remove this. Are you getting this? Right? So if escape character is a part of data and it is also coming into the data, then what transmitter side? At the transmitter side, what will be done? It will put one more escape character before the data. This is the data. I repeat, this is the data and this is the byte stuffing. Both are escape character, but this is the data and this is byte stuffing. So whenever two escape characters come at a time, right, after one, another escape character will come, then receiver will understand that this is a part of data, so it will remove only one escape character. So unstuffing is done in two ways. One, whenever the pattern is same as the flag, and second is whenever escape character is also a part of the data. So actually we are adding two extra bytes. So 2 byte stuffing will be done, right, in the original data. Same thing is shown in the figure. Let me show you the figure. Yeah. So extra 2 bytes are there that they want to say. So whatever frame sent is like this. whatever frame received is like this. But whenever receiver will unstuff this data, then what will happen? This escape character will be removed because it is before flag. This escape character will also be removed because this is before the data, original escape character in a data. Okay, so 2 extra bytes will be unstuffed at the receiver side. So processor will understand that this is the original data coming from the upper layer, or the going to the upper layer. Is it okay, everyone? Are you getting what is byte stuffing and unstuffing? If you have any problem, you can ask me. How many escape character needed to do stuffing if data is same as flag? 1 or 2? Only one.
Hello.
Only one escape character is required if it is same as flag. Okay, and 2 escape characters are required for one for the data, original data, and one for the stuffing. Yeah, Yogaraj understood. Okay, any other students have any doubt? I know this is a little bit complex. That's why I have explained this into the paint.
Hello, ma'am.
Yes.
Can you please explain the escape character once more?
What I need to explain?
The escape character.
Escape character. See, escape is nothing but a key of keyboard which will be represented by ASCII code of 8-bit. Right? So escape character can be represented by 8-bit code. Now, what I want to say is that whenever the flag pattern will be repeated into the data itself, so how a receiver will come to know that this is the end of a frame or this is a part of data. So mostly people have think that escape character, escape key is the least used key into the keyboard. It is the least used character we are using into the keyboard. So why don't we put escape character whenever the same pattern we are putting into the data? Okay, so they have put the escape character here. But by putting the escape character, they came to know that, okay, let's say in some case, if escape character is a part of data, then what we will do? So they have used another escape character in a stuffing manner to hold this escape character in a data itself. Okay, so escape character is nothing but a combination of 8-bit. Actually, not only escape character, every character is a combination of 8-bit. But we are putting some extra bytes, extra bits over here because of this pattern. And because of removing this problem, we have put one escape character, and this is creating another problem. So that another problem is again removed by the same character. So that I have explained. So at the receiver side, this 2 byte will be unstuffed, and the original data you will get as it is. No problem will occur. Is it clear, Chinyadi? Yeah,
Yes,
yeah.
ma'am.
Any other students have any other doubt? Any other students have doubt? Just a minute, guys. Okay, so that we have studied into the next topic, that is byte stuffing and unstuffing. If there is no problem, then we will move the next one. First we have seen, let me tell you, first we have seen that framing will be done into the data link layer. In that data link layer, 2 types of framing can be there, fixed size or variable size. If you are talking about variable size framing, then in the variable size framing, we have started with the first type of protocol, character oriented protocol. Character oriented means we are talking about the data in form of characters. Right? And characters I already explained you. Character means a key of keyboard you can consider. So each character can be represented by a 8-bit of data. And you are adding the start and stop bit, header and trailer bit for the representation of starting and ending of the frame. But whenever you are adding this type of bit for the variable size framing, some problem can be occur. That problem I have explained, that the same pattern can be come into the data also. To remove this problem, what we have done, we have added one extra byte into the data in form of character. Hello, am I audible, guys? Actually, there was a problem in the internet connection. Just a minute, let me share the screen. Okay, so I was telling you that what we have discussed so far in the character oriented protocol. So if you don't have any doubt into the character oriented protocol, so let me give you one note which is very important. Byte stuffing is the process of adding one extra byte whenever there is a flag or escape character in the next. Right, so you have to do the byte stuffing in two cases. One is there is a flag in a data, or there is an escape character itself in the data, right? Then you have to add one extra byte. Okay, second is bit oriented protocol. So far we have studied character oriented protocol, that you are transmitting the data in form of characters. Now, if you are representing the data in form of bits only, you are not representing the character data. You are not representing the data in form of code, right? You are representing it in form of binary bits only. So, if the data is bit, then what will be the structure? So, structure is again same. No changes into the structure. What is the structure? Variable number of bits can be there in the data. Header and trailer bit will occupy the same details what we have studied earlier. Flag bit is represented as a starting and ending of the frame. Starting and ending of the frame, right? One type of pattern, 8-bit pattern is given over here, 0 1 1 1 1 1 1 0. Same way it is for the ending of the frame. Now again, before going towards the problem, let me give you one more note which is important. Bit stuffing is the process of adding one extra zero whenever 5 consecutive ones follow a zero in the data, so that the receiver does not mistake the pattern, this one, for a flag. What they are saying, this is the 8-bit of data where 6 consecutive ones are coming. I repeat, 8-bit of flag in which 6 consecutive ones are coming. So this type of pattern can also be possible in the data. I repeat, this type of pattern can also be repeated into the data. So whenever this type of pattern will come into the data, receiver can interpret that this is the end of a frame. So again, the same problem will be done. But here, to fix a problem, we are not going to add byte into the original data. We are not going to do byte stuffing. We are going to do the bit stuffing. So what is that bit stuffing? Let me tell you. For example, this is our data, original data, which is coming from the upper layer in the transmitter side. Okay. So in the transmitter side, if this data will coming from the upper layer, then what is the data? In this data, consecutive 6 ones can be there, right? Which can be same pattern as the flag, right? Some data can be there which is having the same pattern as a flag. So 0 1 1 1 0 1 1 1 1 1 1. If this type of pattern is there, in the data, then what transmitter side will do, right? So in the transmitter side, one extra bit will be added, and that extra bit will always be 0. And what is it? Let me tell you. For example, 0, 1, 1, 1, 1, 1. Only after 5 ones. We will not go up to the 6 ones, which is the pattern of the flag. After 5 ones, we will add one extra 0. And whenever this extra 0 will come, after 5 ones, the receiver will understand that, okay, this 0 is the extra bit, I had to remove it. I need to remove this because this is not part of the data. This is the extra bit which is added to remove the or fix the problem of the same pattern as the flag. Okay, and it will remove the 0 and it will continue with the reading next bits 1, 1, 0, 0. But again, the same problem can occur. What we were facing in the character oriented protocol. Let's say this type of data 0, 1, 1, 1, 1 like this. Let me tell you here. Let me show you here. 0, 1, 1, 1, 1, 1, and after 5 ones there is a 0 in a data itself. So if receiver will remove this 0, original data it will not get. So whenever the same pattern after 5 ones, if there is a 0, then again one extra 0 will be added. Same like escape character. That if escape character is a part of data, then you have to add one more escape character. So that receiver can understand that, okay, I need to remove only 1 0, second 0 is the part of the data. Okay, so this 2 extra bits will be added, and that is known as bit stuffing. And at the receiver side, these 2 extra bits will be unstuffed and you will get the original data which you can send to the upper layer. Anyhow, see the same. Character oriented and the bit oriented protocols are almost the same. The only difference is in the character oriented protocol, we are dealing with the multiple of 8 bits. So we are adding the 8-bit stuffing also. And here we are dealing with the single bit. So we are going to add a single bit stuffing over there. Right? So single bit stuffing is always they are putting at a 0 as a 0. Any doubts to anyone into the bit stuffing or in the bit oriented protocol? Any doubts to anyone in the bit oriented protocol? Ma'am, it's a fixed sequence that after 5, 1 is coming 0. No, Ravi, it's not a fixed sequence. It is just, they have given one example that this will be the good pattern. If you will follow this sequence, then it will be a good pattern which you can solve easily. Otherwise, if another pattern is there, then you can solve it in a different way. But this is the way, by stuffing the extra bits. And Suman was also asking some question. What if there is a 3 alternating escape in a data section? Okay, so you are saying about the original data. In the original data, if 3 escape characters are coming in sequence, right? Suman, in the original data, you are asking about 3 escape characters are coming in a sequence. So let me tell you, Suman, there can be problem even with the 2 escape character incoming in a sequence. Generally, whenever you are studying the communication fundamentals, there is a solution for one problem, then another problem can come. And whenever you will find out the solution from the another problem, you will get the another problem again. So this type of problems are there. But we are trying maximum possible solutions. So let me tell you, if you are talking about the 3 alternating escape sequence, then definitely they have tried or they have done so many trial and error, and they have found that escape character we are not using much. Why we are going to use 3 times escape character together in a data? Generally we will not do, right? Suman, what I want to say is, in a communication, they are finding out, they are working on a probability actually. They are working on a probabilities, that what can be the probabilities to sending the data. And that's why they have used only escape character as a byte stuffing, because they have found that maximum probability to not use a character much into the data is escape. That's why, right? So they are finding out the solution by using the maximum probability. Definitely 100% perfect result cannot be getting the communication if some type of problem can be occur like this, the 3 alternating escape in the data section, but generally it will not be there, right? 99.99% this type of problem will not occur, right? Ravi Singh, ma'am, escape processing bits. Sorry, Ravi, I didn't understand. You are asking me something, or you are, ma'am, it's fixed sequence that after 5 and that is okay. Escape processing bits means what? What do you want to say? Ravi, why escape is coming? Yeah, I given the answer, no? Why escape character is coming, right? Escape character you are using for byte stuffing, and if it is a part of data, then you are using another escape, but generally this type of problem can occur less. If your doubt is not clear, you can ask me by unmuting yourself, because maybe in the chat box I will not interpret the question in the same way what you want to ask, maybe. Okay, so any other doubts to any other students regarding this? No doubts into the byte character oriented protocol and the bit oriented protocol? Great. Then the next topic is flow and error control, but I cannot start it today because in 5 minutes I cannot give you even introduction in detail of flow control and error control. So today I'm going to free earlier. I'm giving you break earlier. Fine. So okay, we will start the data flow and error control into the next lecture. Is it clear, everyone, up to this? And keep remember, in next lecture, I am not going to repeat this character-oriented protocol and the bit-oriented protocol. We will directly start flow and error control. So if you have any doubt, you can ask me. And if not, write your enrollment number. That will done very rapidly. See, screen is in front of you. You can see how fast the enrollment numbers are coming into the chat box. Okay, no problem. After writing your enrollment number, you can leave the meeting. After writing your enrollment number, you can leave the meeting. This is our talent of attendance. Yes, Sunny, I know. I know your talent. Okay, those who have written their number, they can leave.